Hi, I'm Rob Berenwick from the American Boat and Yacht Council, and today we're going to show you how to test this power pedestal to confirm you have the appropriate power going on to your boat. With me today is Ed Sherman, who is the author of many books on marine electrical systems, as well as the Vice President of Education for the American Boat and Yacht Council. So, Ed, what's in store for today? We're going to do some testing here with a tool that you really like to use.
Yeah, we're going to show you how to use several tools that I've been using for some time now to confirm power integrity, getting on board a boat, as well as a tool that I use to look for ground fault leakage that is directly associated with a lot of the in-water shock hazards and in-water shock deaths that we've seen and had experience with around the country. I want to preface everything though by saying that the tests that we're going to perform are they actually go a little bit beyond those prescribed by the National Fire Protection Association, NFPA, in their electrical codes applying to marinas. Their standards quite specifically state that these dock pedestals need to be checked and their integrity confirmed at least annually. And they get very specific about things that need to be tested. Ground integrity, looking for frayed wires, things of that nature. We're going to perform more tests than they actually demand, but I will tell you that if you're a marina operator, you really need to take this testing, this annual confirmation seriously. Now, the things that we're going to show you how to do today, you can do pretty easily with the tools that we're going to use, but I would add that if you do find anything wrong for legal reasons, the most appropriate action would be to bring in a licensed electrician to minimize any liability risk on your part. So with that said, Rob's going to start using these tools, and we'll look at what it can do and what's implied by the various tests that he's going to make.
So our next test is another right-hand arrow. This one, it looks like it's peak voltage, 166.7 volts. So what is this telling me?
Okay, peak voltage is an interesting and kind of important value. You're actually measuring, because this ideal short test is measuring values at true RMS, which is acronym for root mean square. In electrical engineering, that's an important value. So we have our measured peak, and we're going to compare that to a theoretical peak. And your theoretical peak can be derived by taking your initial voltage reading, which was, help me, 116?
Yeah.
And you're going to measure that time, or multiply that times 1.414 to get what the theoretical peak should be with a perfect sine wave. So you compare the theoretical peak with your measured peak, and if there's anything more than about a 2 to 3 or 4% differential, it's indicating harmonic distortion in the power feed coming to the boat. Excessive harmonic distortion can be the cause for noise and things like audio amplifiers or funky screens on flat screen televisions and things of that nature. Mm-hmm. Okay. So it's a pretty good test using relatively inexpensive equipment. Harmonics analyzers on their own are priced in the $3,000 to $4,000 range, so it's not a tool that everybody's going to want to run out and buy next week. This gives you a relatively inexpensive way to at least get a sense for if there is excessive distortion.
All right, let's see what we've got next here. Okay, so this one is for our frequency. It says we're running 60 hertz, so can you tell us What is that?
In my experience, testing frequency delivered by utilities around North America, you're never going to see it off. I've never found it to be deviated from the 60 hertz.
Okay.
That said, let's say you were using this tool to check the output from an AC generator installed on a boat, which it's quite useful for doing that too. Any variation in frequency is going to be implying that you've got an RPM governor related issue with that generator, and it's going to need some adjustment. 60 hertz should be 60 hertz. The tolerance, again, from the ABYC standard is plus or minus 5%, but I will tell you that that is a very high number in today's world. Most electronically controlled AC generators available in our marketplace today for the marine service are going to pretty much assure you 1 or 2% accuracy to that 60 hertz frequency value, and they do achieve it.
So testing that generator will just be taking this unit and bringing it on board, running the generator and plugging it into an outlet that's on board to test and confirm frequency.
Absolutely. As long as that receptacle is supplied power by the AC generator when it's switched to generator mode on the boat, you can use it in that way. Yep.
Okay. So I can use this to test stuff on the dock and on the boat. That makes it really convenient.
Yep. It's a very valuable tool for testing AC systems.